to chapters 3.4 through 3.6 pre-assessment. This is the detailed answer key. So it says evaluate the function when x equals -3, 0, and 5. So those are three different inputs and they're looking for the outputs. So this is a single input, this is a single input, and this is a single input. So what would the outputs be? So the way we notate this, we'll do the first one, f of -3, we're going to input -3 for the variable x, and technically that's just being inputted into here for notational purposes. Here is we will be simplifying. So we're going to write -3 plus 8. So f of -3 equals 5. Then we do it for f of 0. We are going to input 0 in for x, and we get f of 0 equals 8. And the last one, when f of 5, and we insert 5, or substitute 5, and we get f of 5 equals 13. So those are my three outputs for each of those individual inputs. We'll do it again. H of -3 equals 3 times -3 minus 9. H of -3 equals -9 minus 9. H of -3 equals -18. H of 0 equals 3 times 0 minus 9. H of 0 equals 0 minus 9. H of 0 equals -9. And h of 5 equals 3 times 5 minus 9. H of 5 equals 15 minus 9. H of 5 equals 6. Let P of t be the number of people in a stadium t hours after 11 o'clock. Explain the meaning of each statement. So this output, this is the output. This output represents the number of people in the stadium. And then t is the input, and that represents the number of hours after 11 a.m. So when we see P of 3, that's the number of people 3 hours after 11 a.m. So this represents the number of people at 2 p.m. So technically that's 2 p.m. So the number of people at 2 p.m. is the same, and P of 5 equals the number of people 5 hours after 11, well, that's a horrible, 11 a.m., also known as 4 p.m. So the number of people at 2 p.m. is going to be the same as the number of people in the stadium at 4 p.m. That's what that statement means. This would be the number of people, P of 6, equals the number of people in the stadium after 6 hours, which is going to be 5. That's a horrible 5 also, 5 p.m. And P of 2.5 equals the number of people in the stadium after 2.5 hours, which is going to be 1:30 p.m. So what this says is the number of people at 5 p.m. is going to be less than the number of people at 1:30 p.m. So the number of people in the stadium is going to be less at 5 p.m. than the number of people in the stadium at 1:30 p.m. Find the value of x so that the function has the given value. So what they've done here is they've given us the output. K of x equals the output, and it says, hey, the output's going to be 49. So we can take this statement, K of x equals 7x, and we can substitute the output for. So we can rewrite this because we know what K of x equals. K of x equals 49, so we can substitute it, and we can solve for x. So we can actually find what the input, so the input is going to be 7. So when we input 7, our output's going to be 49. Same thing here. You have an output, which is 19. We will substitute that output in for that same notation. So we write 19 equals negative 5x minus 1, and we'll solve it. So we'll add 1 to both sides. We get 20 equals negative 5x, divide by negative 5, and negative 4 equals x. So when we have an input of negative 4, my output would be 19. That's all it wants to know. What is the input when the output's 19? Graph the linear function. This linear function is in the form of slope-intercept form. Y equals mx plus b. So we can pull out those two pieces of information. I know the coefficient of x is going to be my slope. I know the constant adding or subtracting to the variable will be my y-intercept. So my y-intercept is negative 3, so I go down 3 from the origin. And then my slope is negative 2, so I go down 2, right 1, down 2, right 1, and I am able to draw a graph of those points. When I'm given the equation in slope-intercept form, I am going to plot 3 points and label those points. So my line must have arrows, I must have 3 points, and I must label all 3 of those points correctly. That's going to be 1, negative 5, that's going to be 2, negative 7. So make sure that you have those 1, 2, 3, 4, 5, 6, 7, 8 things, 3 points, 3 coordinates, a line, and arrows. So those are 1, 2, 3, 4, 5, 6, 7, 8. I need those things in order to get credit. My y-intercept is 4, and my slope is 2 over 3. So I'm going to plot my y-intercept first. You always have to plot your y-intercept. Slope is from one point to another, so we need to have a point in order to use that slope, which is 2 over 3, which is up 2, right 3, up 2, right 3. Connect those dots. Hey, that was pretty good. Arrows. Coordinates 0, 4, 3, 6, and 6, 8. Those are my 3 points. Make sure 4, 5, 6, 7, 8, 4, 1, 2, 3, 4, 5, 6. Yep, those are correct. The function d of x equals 1375 minus 110x represents the distance in miles a high-speed train is from the destination after x hours. So how far is the train from its destination after 8 hours? Well, we need to understand what pieces. So this train's going to start 1375 miles, 1,375 miles away from its destination. It's traveling at a speed of 110 miles per hour. I see my units, I see my miles, and I see my per hour, okay? And X represents the number of hours, so that's good. So and this is my distance. This is the distance left. So d of x is my output, tells me the distance I have left. 1375 is how far I am at 0 hours, or how far away I start. 110 is the rate of speed per hour, and x represents the number of hours. So how far is the train from its destination after 8 hours? So it wants me to input 8 hours. So it wants to know when is d of 8. So 1375 minus 110, 110 times 8, d of 8 equals 1375 minus 880. 1375 minus 880 gives you 495. 495, I think that was. Make sure, my memory is so short. So what does that mean? So after 8 hours, the train is 495 miles from its destination. Good. So the function d of x equals 13 represents the distance. How long does the train travel before reaching its destination? So when you reach your destination, you are 0 miles away. So you're going to set your function equal, you're going to substitute d of x equals 0. When is my distance 0? And it wants to solve for x. So we want to know how many hours. X represents the number of hours. So we'll do 13 minus 1375. Negative 1375 equals negative 110x divided by negative 110, 110, and we get 1375 divided by 110 is going to give you 12.5. So 12.5 equals x. So it'll take you 12.5 hours to reach your destination. Okay. Graph linear equations. So one of the things that we should notice is that there's only one variable here. When there is one variable, that means that it's going to be horizontal or vertical. And this is going to cross the x-axis at 6. So here's my x-axis. I'm going to find 6. 1, 2, 3, 4, 5, 6. And I'm going to make a vertical line. This is the equation. I'm going to make a couple points, 2, and I'm going to write, I think on the assessment I asked that you plot at least 2 points. So this is going to be 6, 1, 2, 3, 4, 5, 6, 5, and this is 6, 1. And we notice that in each of those coordinates, my x value is 6 because that's what it says. X is always going to equal 6 no matter what my y value is. So that's how I'd like to see that. You're still going to have to draw a line. You're still going to have to draw arrows. You're just going to need to only do 2 points opposed to 3 points unless it states differently on the directions. I can't remember right at the moment how many points I asked for this. I think it's 2. Y equals 3 halves. Again, we should notice there's only one variable, so we know it's going to be horizontal or vertical, and it says y equals 3 halves, so it's going to cross my y-axis at 3 halves, which is 1.5, and it's going to look like that. And I put arrows, and let's make a couple points, and let's label those coordinates. So this is going to be, I think that's -5, 3 halves, and this is 3 halves. 1, 2, 3, 4, -5. And we notice, again, this says y equals 3 halves, so my y values in both of those coordinates are 3 halves. If your y is always going to be 3 halves, we're going to have a horizontal line. Now we're given it in standard form. Standard form, we are going to use the x and y intercepts. When we look for the x-intercept, we know that y equals 0. So we're going to plug in 0 for y, and we get 2x plus 0 equals 6, which is 2x equals 6. Using the cover-up method, you would go straight to this statement, divide both sides by 2, and you get x equals 3. That is the x-intercept. That is the point 3, 0, because I plugged in 0 for y, so we better have 0 as my y value. And 3, 0 gives me this coordinate right here, 3, 0. And then if I find my y-intercept, I know my x value is always going to be 0. So we plug in 0 for x and solve for y. 0 plus 3y equals 6. 3y plus 0 is 3y. And using the cover-up method, you would go directly to this statement, divide both sides by 3, and we get y equals 2. And that, you plugged in 0, you got 2. 0, 2 would take you to this location, 0, 2. We connect the points, draw arrows, 2 points, 2 labeled points. Do not make the mistake. This point, 3, 2, is incorrect, not a solution. This is not a solution on that, for that linear equation. Do not make the mistake of 3, 2. You have been duly noted. So using the cover-up method, I'll show you the cover-up method kind of quick here. Let's do this. Let's do this. So if we want to find the x-intercept, we would cover up. No, that didn't work. We would cover up. This is going to be a stinker. We cover up the y value. And we notice that we get the statement 8. I didn't want red. We get the statement 8x equals 16. That's the x-intercept. We cover up the y value, the y term. Divide by 8, and you get x equals 2. So I make a dot, on the x-axis, which is 2. If I want to find the y-intercept, I'm going to cover up the x term. So the y-intercept, I cover up the x term. And that gives me y-intercept. That gives me negative 4y equals 16. Divide by negative 4. And we get y equals negative 4. That's my y-intercept. I go down to negative 4. And I have my 2 points. So the cover-up method is very useful to help be more efficient, to really get that pretty quickly. I swear to you, this smartboard sometimes drives me absolutely bonkers. So this is 0, negative 4. This is 2, 0. Whenever you're plotting the x and y intercepts, you're always going to just have to plot 2 points and label those line with an arrow. So that's the most efficient way. We again would get, if we're looking for the x-intercept, we'd have negative 12x equals 36. If you're finding the y-intercept, you have negative 3y equals 36. You can do this super quick and easy. You get x equals negative 3. Divide by negative 3, you get y equals negative 12. Those are my intercepts. It is not a point. It is not negative 3, negative 12. Negative 3 on the x-axis, negative 12 on the y-axis. Connect the points. Arrows, label. We have negative 3, 0. We have 0, negative 12. And you are good to go. That's how fast. You can get negative 1/2 x equals negative 2, negative y equals negative 2. We're going to multiply by the reciprocal, and we get x equals negative 4. We're going to divide by negative 1. We get y equals negative 2. So x is -4, 1, 2, 3, -4 on the x-axis, -2 on the y-axis. Connect the points, -4, 0, 0, -2. That's how quick, if you're really good, you can move through these problems relatively quickly. You have 17 problems on the assessment. If you are not familiar with this work inside and out and proficient and mastered it, then you're not going to have enough time to complete it. And therein lies some of the big issues, is that you're not putting enough time into being prepared. Being prepared means knowing it inside and out. So this is graph the equations. There are 3 equations here. X equals -2. It's going to cross the x-axis at -2, and that looks like this. That is that line. And then we have to graph y equals 2. And that is an equation that looks like this. And then we have to graph the equation -x plus y equals 2. So if we want to find the x and y intercepts, -x plus y equals 2. My x-intercept, -x equals 2, divide by -1. X-intercept is -2. Y-intercept, y equals 2. That's my y-intercept. So I'm going to make 2 dots for those. X at -2, y at 2, and then I'm going to make a line. And let's do a line in this fashion so we're good. So that looks like that-ish. Good. Let's fatten it up a little bit. So it looks like that's a little too fat. Oh, let's make it also. Let's make it a little bit more transparent. A little bit more transparent. Now it looks like a marker. Yes, that actually looks just like it. Okay, so we graph those 3, find the area of the enclosed figure. So the enclosed figure is this, and that looks like a triangle. How do we find the area of a triangle? So we go back to this. Area of a triangle equals 1/2 base times height, where the base and the height are perpendicular. So this has a base of 2 and a height of 2. So area of this triangle equals 1/2 times 2 times 2, which area of triangle equals 1/2 times 4. Area of the triangle, that's a T, equals 2. 2 units, 2 squared units. Squared because you have 2 dimensions. So find the area would be 2 squared units. Don't know if they asked for that. They might. You lose track of how many 2-point baskets and how many 3-point baskets a team makes in a basketball game. The team misses all the 1-point baskets and still scores 54 points. That's not a team that's very good at the free throw. The equation 2x plus 3y equals 54 models the total points scored. What do the terms and coefficients of the equation represent? Love this problem. So, in the equation, x equals the number of 2-point baskets made. 2 equals the number of points for a 2-point shot. Y equals the number of 3-point baskets made, not attempted, made, and 3 equals the number of points for a 3-point shot. And then 54 is the total points scored. Total points scored. So that's not how you spell scored, scored. So the total points scored equals the sum of the 2-point baskets, 2-point basket made and 3-point baskets made. So you're going to do that. I like that. Can the number of 3-point baskets made be odd? So give me an odd number. That's 15 equals 54. And what we would do is we would subtract 15. And the issue here is you have 39 needs to equal the number of 2-point baskets made. And we know that you can make an infinite number. No number of 2-point baskets will ever produce an odd number. So can the number of 3-point baskets made be odd? No, because no 3 times an odd number is never going to leave us with an even number of points left. So the answer is no, it cannot. 3 times 3 is 9. 3 times 5 is 15, 3 times 7 is 21. All of those will produce odd. Every multiple of 3 is an odd number. So subtracting an odd number from this even number will produce an odd number. And then I will never have an opportunity to make a number, no odd number will ever be produced is a product of 2. There you go. Graph the equation, interpret the intercepts. So if we're going to graph this, we're going to graph it by finding the x-intercept. X-intercept would be 2x equals 54. Divide by 2, you get x equals 27. And 3y, find the y-intercept. 3y equals 54. Divide by 3, y equals 18. I think it's 18. 18, yeah. 54 divided by 3, yeah, 18. Okay, so x is 27. Let's go multiples of 3, yeah, because that'll work. So 3, 1, 2, 3, oh, that would be 9 right here. Would be, so this point would be 27, 0. And 1, 2, 3, 4, 5, 6. This point would be 0, 18. And it would not be a straight line. It would not be a continuous graph. It would be discrete. And we also know that none of these, we just went by 3s. That was bad because those are not going to be solutions. I'll come up. Those would not be solutions because we can't have odd solutions. But yeah, so graph the equation. It's going to be points. There will be specific points that will work. Not all points will work, but it will look like this. So we graph the intercepts, and it's somewhere in between there. I think it asks find 4 possible solutions. So what would work? Let's do 3. Let's see what we get here. 54, that's 6 plus 3y equals 54 minus 6 minus 6. 3y equals 48, I think it is. Yep, 48. And 3 goes into 48. 3 is divisible by 48, and that gives me 16. So that would be 3 2-point baskets, 16 3-point baskets. That would be one solution, because if we have 3 2-point, well, let's do 2-point times 3 plus 3-point times 16, that should equal 54. That's 6. That's 1848, which equals 54. So that solution works. And let's think of another one. Let's plug in 6. 3y equals 54. That's 12 plus 3y equals 54. That's minus 12. 3y equals 42 divided by 3 divided by 3, y equals 14. So that solution is going to be 6 2-point and 14 3-point shots. That's good. Now we can also, let's erase this real quick. We can also plug in for y. So if we want to plug in a value for y, so we can do 2 equals 54. So 2x plus 6 equals 54 minus 6. 2x equals 48 divided by 2 divided by 2. X equals 24. So that means we would have 24 2-point shots and 2 3-point shots. So that would be our other way of finding 4 possible solutions. And then we can do one more. So let's plug in, well, we know that it can't be odd, so I would never plug in an odd number. Let's plug in 6 3-point, 54. So 2x equals 8 plus 18 equals 54, minus 18 minus 18. 2x equals 36 divided by 2 divided by 2, x equals 18. So 18 2-point shots and 6 3-point shots would equate to 54 total points in the game. Describe the slope of the line. So we would first find points that are at intersections on the grid, and now we would do rise over run. Slope equals rise, that's a horrible, rise over run, and that's up, down, over, right, left, up being positive, down being negative, right being positive, left being negative. So I'm going to see how much do I go up or down from one point to another. So I'm going to go up 1, and I'm going to go right 2. So up 1, right 2 translates to positive 1 over positive 2. And we notice that that would work any other way. If we went from this point, if we went from, let me show you the point. We go from this point to this point. We don't have to go to immediately adjacent. We'd still get there. We'd go down 2, and then we go left 1 2 3 4, left 4. So translate that, down 2, left 4, down 2 is negative 2, left 4 is negative 4, which simplifies to 1/2. We always have to simplify our slopes. Not only in that, if I get a slope of 4 over 1, I want it as 4. That is your answer, not 4 over 1. Do not give me slope as a fraction that is not simplified. So remember, see who listened to the video. Only answer. This is not the answer to this question, but you understand by that. Good. So we can find the increments. So that's going to be plus 5, plus 5, plus 5. That's going to be plus 6. That is plus 6. This is plus 6. Remember, it's the rise over the runs. It is the difference of y's over the difference of x's. And when we find this gap, we're finding the difference. So it's going to be 6 over 5, so 6/5. We would not give slope as a mixed number. Do not give it as 1 1/5. Do not give me that. Don't give it to me as a decimal. Do not give me as 1.2. No decimal, no mixed number. Slope is a fraction or a mixed number, or improper fraction. So here we have plus 0, plus 0, plus 0. Here we have plus 3. Not plus. Ooh, okay, that's okay. Plus 3. Here we have plus 7. Here we have plus 3. So each slope, that would be 3 over 0. This would be 7 over 0. This would be 3 over 0. These all simplify to no slope. So that is still a linear equation. They don't have to be the same. These don't have to be the same. They just have to produce the same slope. That has to be the same. So my answer for this one is no slope. Remember, it's the y's over the x's, and you can't have 0 in the denominator. Here we have plus 1. Here we have plus 4. Here we have plus 8. Here we have plus 0, plus 0, plus 0. So we get 0 over 1, which equals 0. We have 0 over 4, which equals 0. We have 0 over 8, which equals 0. So my slope equals 0. 0 can be a value. Graph the linear equation. We know it's in slope-intercept form. This is my y-intercept. This is my slope. We can do this fast. Y-intercept is 4. My slope is up 2, right 1, up 2, right 1. I connect my dots. And that's good because I don't want my line in blue. I want my line in black. Boom. I'm going to put arrows. When it is in slope-intercept, I need 3 points. And my intercept is going to be one of those, 1, 6, and 2, 8. So I need 3 points. I need those 3 points labeled. I need a line with arrows on both sides. Those points need to have parentheses around them. If you don't have parentheses, you can't just label points 0, 4. That's not a coordinate. Also, duly noted, been noted. Now this is in standard form, so I'm going to find x and y intercepts. If it's not in slope-intercept form, then don't use slope-intercept form. Use standard form using the intercepts. Use whatever they give it to you. If it's in standard form, find the intercepts. If it's in slope-intercept form, use the slope and the y-intercept. X-intercept is 2, y-intercept is -10. So in this one, I only need 2 points. And that is 0, -10. This is 2, 0. So only 2 points are needed. Also in standard form, so I'm going to use the intercepts. I'm going to multiply by -2, which is the reciprocal of -1/2, and I get x equals -2. Those are my 2 intercepts. See how fast we can graph nowadays. Oh, I swear, drives me crazy. And I keep expecting it not to do that to me, but it does. And it will continue because it's broken. -2, 0. That's a horrible coordinate. And this is 0, 0, 1. 0 on the x, 1 on the y, and we're good to go. Same thing. X-intercept equals 9. Y-intercept equals 3. This is literally taking me x, we're going to go 9, y, we're going to go 3. This is taking me 30 seconds to do. And now we don't want to rush and do it wrong, but we do want to be efficient. So we can be doing these problems in less than a minute. That's 0, 3, and this is 9, 0. A linear function h models a relationship in which the dependent variable decreases 2 units for every 3 units, the independent variable increases. The value of the function 0 at 0 is 2. Graph h, identify the slope and intercept. So the value of the function at 2 is 0. When we plug in 0, we get 2. Ooh, this is a little tricky. the value of the function at 0 is 2. So that's the tricky part. Is it 0, 2 or 2, 0? The value of the function at 0, so the function equals the value of the function. The value of the function is 2. Now I'm going to say 0, 2. So I'm going to say this is the input, this is the output. The value of the function is 2. So when x is 0, the output is 2. And so we have a point, and we know that the slope is going to decrease. So it's going to decrease 2 units. Well, let's make that point first. The value of the function, 0, 2, 0, 2. And then it's going to decrease 2 units for every 3 units. So that's positive 3. The independent variable increase. So for every 3 units. So so it's going to go down 2 and right 3. So it's going to look like that. Down 2, right 3. Looks like that. We have it. That'll be real interesting to see if I am correct. Boop, boop. That is the point 0, 2. This is the point 3, 0. And this is the point 6, negative 2. It looks pretty good. I like it. And that's the last question. All right. I will be honest, you're not going to see that question on the assessment. You won't see that. But good luck.